Okay, guys, welcome back. For this lecture, right, I want to talk about more about how to manage the IoT data. Yeah, IoT data that we send to the cloud. Yeah, this is where we actually stop short. Yeah, from the previously we talked about the sensor node generating the data, sent to the edge device, IoT gateway, perform something what we call store and forward to the cloud. Yeah, and then to the cloud. And then we also talk about the cloud that which is can be in a public cloud, can be in a private cloud, hybrid. Yeah. We talk about cloud have a place to store this data. Yeah, that's where we stopped. I think it's very important for us to know that how this data are actually stored. Yeah. So in this chapter, we're going to go in depth into that. If you come to think of it, the IoT data are very similar, have very similar characteristics with this big data. In fact, it's one of the reason of big data where imagine you have a huge number of IoT sensors. They're actually, sensing, producing data, and then all this data will have to send to the cloud for storage, processing. And if you see the characteristics, these are the five characteristics. It's exactly like big data. Yeah. Number one is high volume, high velocity, and if you imagine that every sensors are reading the sensing every minute, uh, and there are 10,000 of them, you can imagine that the amount is huge. The speeds a lot, yeah. Probably everyone will be, the server will be receiving um, data non-stops. And then you could have a variety where the sensors could be different type. You can have simple sensors such as temperature, pressure. Those are the simple one. Or you can have some really high velocities data such as the audio, video, vibrations. These are the one that's probably sending thousands or tens of thousands of data points in a second. Okay, so therefore, it's high velocity, and because of their different type variety, and of course, velocity. We'll talk about that in a short while, and also the value extraction. Yeah, so you can know that IoT when you scale up is challenging. Now, of course, in the university setting, small systems, all this might not seem that demanding to many of us. As I mentioned, high volume, thanks to that the data is continuous or coming velocity. Yeah, some of them have high sampling rate. Okay, if you should remember one of our lecture early, we talked about sampling rate. Now, high sampling rate, then you have huge amount of data, and yes, and all send it in, then you have high velocity, especially when your IoT system requires real-time processing. This is even much more uh, challenging. Yeah? Okay, we have variety, okay, different type. Okay, and velocity actually refers to reliability, accuracy, and trustworthiness of your data. This is why earlier when we talk about security, your sensors is very of your sensor node is very crucial, because you do not want people to swap sensors or add in not that trustworthy sensors or malicious one, then you actually reduce uh your data quality significantly. Yeah. Mm, Not only that, there are lots of things we have to consider as well. For example, for example, your sensors it's not something that will be evergreen, right? They might uh, reduce accuracy over the years, or sensitivity over the years. They start to become less sensitive, or they are not their calibration, they need calibration. They are not over the operation during the operation. They become inaccurate. That it will also affect you as well, the whole system. Therefore, again, this will be something very interesting where we need to have a mechanism to actually detect um, whether if the sensor is operating normally, optimally, or whether it requires calibration, maintenance or replacement. Yeah, these are things that you have. Uh, is a I will always say that if we don't really run an IoT solution, we only do it like for short term. You won't come across of all this problem. But in the real world, unfortunately, most of the system requires long-term operation. And all this that I mentioned to you are real problem that people now are developing a lot of solution to solve them. It's not just about getting the sensors connected and transmitted data. It's actually more than that. Of course, at the end of the day, the more important thing is the value of the data. Now, this is where, if you're doing your project, you realize that I ask you to, think of what can you get out from the data that you actually extract or you gather. Now, this is very important because uh, the data that you get, of course, some are low-hanging fruits. If you have the data, you can actually straight away can do some optimization and you can straight away see some ROI. For instance, electricity, okay, power generation. You can the moment you detect that someone is wasting or not using the resources optimally, you can actually straight away turn it off, or you can straight away take some action. Then probably you see some ROI very, very quickly, okay, with and without the system. Now, majority of system, majority of the bigger picture of it might not be that um, clear cut. For instance, you want to monitor the vibration of a machine, and then you want to do predictive maintenance. Now again, um, the data that you're sending, it says that yes, high chance of um, that it's going to break down requires maintenance. But again, if you do it too early, it will not be optimal. If you do it too late, then again, it's going to uh, have more serious consequence. So therefore, you need to find the sweet spots where you can actually make use of the data and create the highest value. That is actually again something very very challenging for many of us. Yeah. So um, again, but that's if you come to that, that's where the value of IoT systems lies. Otherwise, you just collect the data and nobody knows what to do with the data. That it would be pointless. Yeah, and that is also why a lot of IoT solutions fail. Yeah, basically their job, they were thinking that I just collect the data and then I visualize it on a dashboard and that's it. My job is done. But unfortunately, if you do that, the the value of the system is very, very low, uh, and it's not sustainable. Excuse me. All right, let's talk about when you have software to actually take in application. Now, this is my favorite design. Usually, I'll design this way. I have an application that take the ingestion, which is the incoming data, and then I have two apps. Usually, I have a application that process them. One is pre and one is post. I will have one that so we get from the ingestion and then start to process the data. So that's another one is through the data that is actually stored in the database. So usually you can have these two, you can think of you have two parts where you can actually design your application to actually process the data. Okay, one is the one that's already in the database, or the other one is straight away from the sensor. Again, this design is also very, very dependent on the type of the use case. There's no one solution or one golden solution for everyone. But all you need to do is that you have to remember that there are these choices that you have. Yeah. Of course, if you want real-time responsiveness, then you probably want to process it before the data is stored in the database. Of course, there are times that you don't process you cannot process things by a single instance. Like for example, vibration data, you cannot do much with a single point. Probably you need to have a series of them before you can make any decision whether this is good or bad. And that probably requires you to have the data to be stored in a certain databases before you can actually process that. Yeah, so again, it really depends on your application. Now, of course, in general, we call them raw data and process data. Raw data, which means the one straight away from your sensor node that we didn't go and undergo any pre-processing or transformation. Process data is the one that you have really done something and process it. For example, maybe you already do some averaging, uh, noise removal, yeah, or some probably some reconstructions. That is what we call process data. Post-process data requires computational power. Now, there are lots of things that we need to do, but this one will be very, very similar to your if you have taken data analytics. Yeah, this is where some very, very similar already. Of course, the data comes in, you want to clean your data. Now, sometimes it really depends on how the IoT system is being designed. Usually for me, right, I like to design it to actually send in high quality data. I would not want the sensor node to actually, send redundant data. For example, after I send once, I send again, or send partial data. That requires huge lots of cleaning process. But again, uh, we have no choice if the sensor node or the sensor systems is designed by third party with maybe have these characteristics that they will just send whatever they have at over the other end, and it is our job to actually clean the data. Otherwise, probably you have a redundant or some transmission of some corrupted data that requires cleaning. And then, of course, once we have all this data, we always need to transform them in a way that we can use them. Yeah. It really depending on how you do processing. Some like a very powerful visualization tool probably needs the data to be in a particular format before that the visualization tool can be used. So therefore, you need to do some data transformation. Of course, you can also do some aggregation. All this again requires processing. Now, doing this kind of processing, all right, usually, sorry, there are more anonymized data, enriched data, normalized data, index data. Yeah, there's just more of data. The thing is, to do all this processing, mm, you have a few ways. One is, of course, you can write your application to do everything from scratch. Yeah, you collect the data, then you process it from uh, very, very, uh, you write everything on your own. Okay, you develop your application, start from the beginning. Or I would strongly suggest you to look into the suitable databases. But the suitable database, right? They all have all these tools, data management, data processing, or data retrieval tools built in already. So in other words, right, if you make use of this the right database, right, I would say that your job will be way much easier and definitely, if you ask me, definitely better than building something from scratch ourselves. Of course, if you must want to try to do something that start from not like you don't want to use any database, then probably this is the flat file. Of course, flat file actually the advantage is not that there's no advantage, and don't get me wrong. Actually, flat file do have advantage, which is it's actually very easy to implement. Okay, probably the programming 101 we always learn that to create a file, you can put all your data into the file. Again, for a small scale, one or two sensors, this approach probably is, if you ask me, I'll probably will choose this because it's easy. Now you can just put all the data into a file, and then if you need anything, you just read from the file, and then you can get going easily. Of course, the disadvantage is that when you grow large, you have to understand that this flat file mechanism doesn't have this acid encrypt characteristics. Where you have race conditions, sometimes like for example, um, two sensors sending exactly at the same point of time, and then your device, have to write them to the file. Of course, if you did not handle the processing well, um, then you have consistency issue, and then of course, if your process is complicated, yeah, let's say you have to update 2 to 3 table for every incoming data, yeah, of probably again you want to capture that transaction. If one of them fail, if you do it using a flat file approach, then probably you have hard time, keeping the thing consistent. Now, all this is a very common thing, especially when uh, the system go huge. One sensor, definitely this is not a problem. Two, okay. Three, you start to feel the pain. Of course, another thing is that this data you put in a flat file, the challenges will be retrieving them, query them. Again, of course, if your sensor data, is very, very small, probably just a few thousand lines, or probably even in the tens of thousands, is still relatively small. Yeah, and you want to do a manual search, retrieve, update, so probably you still can do that. But imagine in the long run, then the file will go really, really huge. Or even if you partitioning them into multiple files, you're going to get lots of files. And to do query will be very, very challenging. More work to do, yeah, on our side. Now, it's not to say that more work is not doable. The thing is, more work tends to, we all understand, the more code that you add in, the higher chance that you're going to introduce more bugs. Therefore, from a software engineering perspective, we always want to use something that is much more reliable. At least, we are pretty sure these basic bugs would not happen. Like for example, consistency transaction will not happen in the established, well established. I cannot say the word will not happen, but very unlikely to happen. Okay, especially in reputable or um, databases, or those proven databases. These are things like very, very rare to actually go wrong. Of course, if you must, one of the database you might be interested to look into would be a round robin database. This one is actually pretty interesting as well, especially when you have a limited storage, but you are monitoring things like 24/7. A round robin database, right, will actually, group the data, process them, in a way that, you can, the most recent one you get to see at very fine grain, for example, maybe you can see the last 1 day at a minute interval. Let's say you want to look at yesterday data, probably at the hourly, until all the way to maybe a week. And then if you want to look at weekly, then it would be on daily basis already. So they kind of in a way that will maintain the data in a round robin mechanism, and they aggregate them into different resolution. The purpose is to maintain the size that is provided for the sensor. This is actually an interesting one. Yeah. Of course, over the years, the storage are getting relatively cheap. We can always use more conventional database such as SQL Server. Okay. Now we talk about SQL. Okay. SQL basically you're going to have lots of choices because it has been around for a very, very long time and it's very, very established. Now, of course, if you ask me the best choice, my favorite choice would be Postgres SQL. My old favorite would be MySQL, MariaDB equivalent. But from what I see in the recent years, Postgres SQL progressed very, very well. So probably you want to do that. I'm not saying that SQL Server, no, Microsoft SQL Server is bad. It's just that you require license to run it. So in terms of clinical costs, you probably want to look at those open source one. But again, Microsoft SQL Server are equally good. Yeah. So from this structured language, we know that we can do all this select, update, delete, insert. Again, I will not dive too deep into here because I believe you have learned this in your database system as well. Yeah. So again, you can imagine that we have a table where all the IoT data comes in. we'll store them into this table. Now, interestingly, this is where you have to start thinking which one is actually better. Having all the sensor data, okay, go into one table, or every sensor node have one own table, or every unique type of sensor have one table. If you think of that, then you start to realize that one of the I would say it's drawback, okay. I would say that one of the requirement of using SQL is that you have to uh, think of the structure of the database upfront. Yeah, upfront. If you have to design that. If you don't design that, probably some new sensors that might not be suitable with your structure, then yes, you have uh, more work. Always remember, it's more work. It's not that cannot doable. Yeah, don't get me wrong. I'm not saying that it's not something that is cannot do. Yeah, you can. You can always go back to the database. Create new table and set a new column for a new sensor node. Yes, you can do that. But again, from an engineering perspective, that is going to be lots of manual work. It's expensive and it's prone to error. Yeah, so um, we don't want to do this kind of thing, especially when you have the system is actually during it's deployed, it's for operation. It's very dangerous. Yeah. Okay. So I believe that you know what is SQL. For those who are not sure, you can read up about relational database management system, RDBMS. Okay, basically it's a table. You have ID, you have name. Okay. I'm showing you this. I just want to share with you a little bit different. If you store database IoT data inside here, usually the primary key is not the most important one. What I'll usually do is that we will have another column where we're going to put in the timestamp. Okay, the timestamp where excuse me, where the data is being created or received at the cloud. We actually create a timestamp. You can actually create a timestamp for not only one but multiple like timestamp when the sensor node creates a reading, generates a reading. There's one timestamp over that, and then the timestamp that the data actually arrive at the edge devices, your IoT gateway, and then the timestamp that actually reach to your cloud. Now you can have multiple timestamp. Okay, so you can imagine that in IoT uh, tables, I will have multiple column. Each column will have their own timestamp, and this timestamp is actually very very useful. Okay, if you ask me, you can use them to actually calculate the latency, the delay of the system, especially it involve multiple sensors. Sometimes we can tell whether it's the sensor problem or the network problem. Yeah. So store in a table format. So it's SQL is very, very simple. You have all this. There are many implementation as I mentioned earlier. I know there's people like to use the SQLite for small application, but please bear in mind SQLite. If I'm not mistaken, the last I remember is does not support the concurrent read and write. Yeah, it doesn't support concurrent read and write. So be very, very careful if you need that feature. Yeah, you probably want to go for something else. Okay, so when we talk about SQL, why is it search fast? Okay, this one will probably due to the indexing. Now we're not going inside the detail of how B3 index is working, but I just want to tell you that yes, when it's indexed, it can actually search way, way faster. And what are the things that you should index from an IoT perspective? Now, that's much more important. You probably want to index them through the sensor when you search, okay, when you query. You really depends how you put the data together. Yeah, of course, if it's one sensor node, one table, then yeah, I mean, uh, you probably just need to make sure that you're able to retrieve through the time Okay, the right index, where we can actually retrieve the time, row quickly based on the time, it should solve the problem. Of course, if you have multiple sensors in the same table, then probably you need to include that into your index as well, the sensor type and also the time, so that when you can extract uh, all the readings from a particular sensor at a particular time range faster. Yeah. So this show you how to create the improve the performance. Probably you have done this in your database classes. Yeah, you should do that. And usually these are they don't do it in a database I-101, but usually the second level of database where you learn to how to optimize your databases. Yeah. Okay. Now, again, I won't go too deep in this one. I want to spend time to move on to the next thing where we talk about NoSQL. All right. Okay. These are the database engine. Mm, okay. Let me move on. Okay. This one, sorry, before we move that, this is also something very interesting. We call it bulk insertion. You remember that we talked about the concept of store and forward IoT gateway. Now, if I take every reading that I got it from the sensor node and then I forward it to the server, of course, the server database will have to ingest or store the data one after another, one by one. But there's one way to actually improve the insertion, the performance, is that you can have the IoT gateway to collect multiple data point, okay, probably in the hundreds of thousands. And then to send the whole thing in a CSV format, of course, you can always compress it, and to the server. And the server does not need to insert the data one line after another. They can do something what we call bulk insertion. Actually, in fact, many databases have this feature called bulk insertion. It's a program provided always by the database that allow you to insert all this data in a single go. Hence, it is actually way faster than you perform insertion into the database one after another. So do consider to use this, especially you have lots of backlog. Store and forward, we always like this way. So after you imagine you can instead of going through calling the insert command 1,000 times, you call the bulk insert one time. You can have your 1,000 records into the database in a single shot. And that's the interesting part of it. Okay, all right. Okay, of course, there are things that we have to do, figure out, like for example, like I mentioned earlier, uh, when there's a change of census, uh, or change of census, which means that you replace them. Okay, of course, the census usually we store them by their IDs, in our database. So when we change the sensor, the ID probably will be different already. Yeah, most of the time will be different. Okay, to distinguish them. They are collecting the data point from the same point, and you want to have the operation continuity. You want to view the whole thing straight. You want to combine them. So in other words, all right, you realize that the database design is has to you have to think of how to manage this as well. Yeah, so how my visualization tool can handle data from old sensor and new sensor without breaking my visualization. Okay, excuse me. Now that is requires some work at the database, which means that you probably want to design in a way that you have logical name and also physical name of the physical ID and the logical ID, where you can actually change the mapping, and then it will not disturb or affect your uh, data collection. That's one thing of it. But again, which database allow you to do that easily? And then another thing is that sometimes your sensor node become much more powerful. For example, at the beginning, uh, during the beginning of the sensor node, it can only sense maybe temperature. and then later on a newer version comes in. Now it can also sense humidity or pressure together. Now you have three readings now instead of one. Then again, if you understand what I mentioned earlier, then you need to go back to the database, update the columns, everything, just to accommodate these changes or this enhancement. Okay, it's lots of work, right? So is there any better way to solve this problem or not? This kind of problem? Yes. Okay. One way is to look into NoSQL. Okay. NoSQL basically is uh, it came in a little bit much later than SQL. SQL is structured. NoSQL is not that structured. Okay. But in a way, it's still they still have their own structures. Yeah. It's just that it has more flexibility in a certain sense of like the number of columns for every record doesn't have to be the exact same. Okay. And all the data sets, depending what kind of data, NoSQL database you use, some of them they just treat them as a documents. Yeah, every reading is as a document where you can actually process it individually. And the one thing good about SQL is that because it doesn't have table relational things to manage. In fact, it's ingestion, the storage, the storing process, okay? The create record process is actually much more efficient. And they can do it in uh parallel, way much faster because of they don't have this restriction. Now, of course, NoSQL is not all perfect kind of solutions there. It has limitation. What is the limitation in NoSQL? The limitation of NoSQL is that it does not provide you things like, for example, transaction handling. Okay. Uh, Sometimes even some of us, we have to manually manage the redundancy. I mean redundancy not in terms of the server reliability, but in terms of data. Okay, what if a sensor node accidentally send the same record twice? Yeah, these are the things that we have to handle. And NoSQL probably it's not designed to do that. Especially transactional operations. Usually NoSQL does not handle that very, very well. Of course, the advantages is that you can scale. When you can scale, which means that you can have horizontal scaling. If you remember what I mentioned, what is horizontal scaling in the last lecture. Horizontal scaling is that when you have a single server and you realize it's not fast enough, you can always add another one, add another two, another three more. Yeah, and you improve the performance in terms of storing and also retrieval. The high availability again, a lot of these NoSQL, yeah, they do design their automatic failover back at the back. So in other words, any server fail, it will take over and then it will manage its data in a way that it will become high reliable, highly reliable. Your data will not go missing as long as uh, there's a threshold one, the number of the nodes that can fail simultaneously. Yeah, usually it depends on how many replicas that you have, how many servers you have. Okay, there are quite a number of NoSQL database that are key value store, document based, column based store, and graph based. My favorite is usually document based store. To me, that is although it's not efficient in terms of size, but to me, I think that is a very good way in storing a lot of data, which is document based. Imagine that every single data point, every census, the records that it generates are actually a document. Yeah, and these databases such as MongoDB, CouchDB, Elasticsearch, they manage them very, very well, and you can actually use them to actually retrieve the readings, everything, your sensor data nicely. But having said so, it doesn't mean that the rest are no good. Yeah. If you use I mean, I used Amazon DynamoDB before. It was really really good as well. Yeah. Uh, it's very very easy to use. Uh, so you can explore this database, and you find them uh, they are very, I would say, natural, okay, especially in storing the data. Now, the pain is usually retrieval. Yeah, the pain of NoSQL, if you ask me, it would be retrieval. You have to uh, sometimes need to do some extra work. You know? I mean, in SQL Server, usually we know SQL, we retrieve data will be very straightforward. Yeah, for this database, all right. Yeah, so you need to put some effort in retrieving and query the data. Now, again, I don't think I'll go deep inside what's MongoDB. You can always go here and try it yourself. And I really strongly recommend MongoDB, over Firebase, if you must. I mean, it's not to say that it's better, but I would say that it would be good that you increase your experience. Yeah, you can use. I think many people know how to use Firebase. I strongly recommend you to also use MongoDB. See the difference for yourself, and this is free as well. It's free as well. If I'm not mistaken, yeah, you can use register uh, MongoDB Atlas. It's actually hosted in the cloud. Um, you can try it out to store some data. Yeah, it's a document base. You can store them as this is how it looks like. Yes. So in other words, if you come to think of it, if you have different sensors with different um, with providing you different data from different sensors from a sensor node, yes, you can have this, uh, in a in a different structure, and you still can retrieve it. Okay, the system MongoDB can find this data for you. Of course, the design is still the same. If for IoT, we still want to put in all the timestamp, yeah, so that we can retrieve the data. We need to store in very importantly the sensor ID. Uh, again, or even if it's no SQL, it doesn't helps in solving the sensor replacement. So a good IoT solution, especially the database, you should always introduce the concept of having a logical ID, compared to the physical ID, where we can actually do the mapping, uh, change the sensors, and it doesn't affect the visualization part. Okay, sensor can be nested. Mhm. Okay, this is a document. I think you can read this up yourself. There are lots of why it can actually reliable and run faster thanks to sharding and replica. Okay, so you imagine that you have multiple servers, each of them holds certain part of it. And the good thing is all these parts operates together, especially in retrieving data. Okay, it's very, very interesting. You can actually explore them. Of course, if you must, let's say you say that okay, performance is something that is uh very, very important to you. Uh, so other than SQL, other than NoSQL, another candidate that you might be interested would be time series database. Now, this kind of time series database, all right, they only focus on time series data structures. Uh, so and it's suitable for IoT because IoT we also taking readings or measurements um, in a time series manner, right? So therefore, if you need performance, yeah, especially for IoT, time series database is not bad. Okay, it's not bad. And in fact, there are a few really recommend, for example, Influx, InfluxDB. The performance is really good. Yeah, high speed. You the amount of data that you can ingest is also very high. You should try it as well. Yeah, so it also has retention policy because they understand that in time series, um, it can grow continuously, over time. But of course, you can set some retention policy, like for example, every week you want to purge or delete all the data that's older than a month. Yeah, you can all do all this configuration in the database. It's by nature. You can try InfluxDB. It's one of my favorite. And of course, over the years, there are more already. Okay, there are more. So which I would think that yes, you can try them as well. So for this, right, for this chapter, just to do a quick recap, we learned a few things. We learned SQL Server. We learned know SQL, we also learned that there are time series type specific database. Mm, you have to know the pro and cons, okay, and then which is the most suitable to use. Yeah, this is something that you need to take note. All right, I guess that's all for this lecture. Uh, Thank you very much.